Hi guys, in this video I'm going to show you how to use arithmetic operations in C++. Let's start out by creating a couple of variables, a and b, and I initialize these to 7 and 5 respectively. And note that both of these values are arbitrary, so I just use these variables as an example. There are few basic arithmetic operations, 5 to be exact, which are plus, minus, multiply, then divide by, and the modulo operator. So let's start out with the plus operator. So I compute the sum here by adding a plus b. And note that we can do literals instead of variables as well. So in this case I have a and b as variables, but I could also do a literal and add a variable to it, such as, for example, 5 plus b, or I could do a plus 17, or I could do even 5 plus 3. So just because I use variables here doesn't mean there have to be, both of these operands have to be variables. So we can use literals either or variables either way. And what this will do is add the two values in these variables together. So it will be 7 plus 5, which is 12, and then assign the result to the variable that I just declared here, named sum. Now I can do the same by computing the difference, where I do a minus b. This will subtract b from a and store the result in the variable named diff. I can compute the product by multiplying a and b, and I can compute the quotient by dividing a by b. So this one here is important. This is called integer division because both operands are integers. Now I'll get back to that in a moment when I output the results. And just to complete the list, the last operand here is the mod operator, which will give us the remainder. So really a mod b. And essentially this will perform integer division. 7 divided by 5. So 5 fits in the 7 once, but we have 2 over. So the 2 units, the 2 integers will be stored as a remainder. So let's output all of these. We have the sum. We have the difference. Then we have the product. We have the quotient. And this was integer division. And last but not least, we have the remainder. So let's run this just to see what we get as output. Here we get added both together as 12 for the sum, 2 for the difference, 7 minus 5. Then 7 times 5, we get 35 for the product. And for the quotient, which is integer division, we get 1. So and then for the remainder, we get 2. So why is this here 1? Since it's performing integer division, it only cares about whole numbers. It doesn't care about any of the fractional part. So anything that is after the decimal point will just be dropped. There's no rounding whatsoever. If the result is 1.4, it will just be 1. If the result is 1.6 or above, it will just be 1 as well. So even if we have 1.999, the result for integer division is just 1. Whatever is in front of the decimal point will be the result. Now, this is kind of the basics for arithmetic operations. We can do the same with other types. If we just use floating point variables like float or double, it would essentially be the same. It would just, for the division operator, it would perform floating point division. Now let's see if we have two integers, how can we perform floating point division? First of all, what we have to do is we have to create a floating point variable. I call this float quotient. Now if we do a divided by b and then assign it to a floating point value, and I'll output this here below. When we do this, this is still an integer value. Well, essentially it's a floating point value, but it's still based on integer division. So let's output here to show you what I mean. So this should, what this will do is I'll take a, which is 7 divided by 5, perform that operation, but it still drops anything after the decimal point. So if, and this would be 1. And then it would store integer 1 as a floating point value, which is just 1.0. And so we still get, we still perform integer division, and we get the result of the integer division. It just happened to be represented as a floating point value. Now what if we want to actually get the true value of floating point division? What we have to do is cast either a or b to a float. And here what we do is we use a static cast to a float, pass one of the values in. I just take a. We may as well just pick b. It doesn't really matter. Now one of these is a float, so a happens to be of type float. So now it will be float divided by an integer, and this will be floating point division. So for floating point division, one value or one operand has to be a float, or double for that matter. And when we run this again, now you can see we get 1.4, which is what we expect for a floating point operation. So bear that in mind whenever you do division. Know that when you have two integers, you perform integer division. If you want to get floating point division, you have to cast one of the operands to be a float. Now, all these arithmetic operations up here, I use the operator with two operands. Now you may use any number of operands you like. So there's no limit to the number of operands. So if I have a third variable here, let's say c, and I want to compute a result, I could do a plus b times c, for example. And I could go on and on and on. I can do divided by 2 and continue as many operands as I want. There's really no limit to it. And any of the operands can be literals, so they don't have to be variables. The only thing I have to keep in mind, or maybe a couple of things I should keep in mind, if it's too long, it makes the code hard to read. So it's better to use like intermediate variables, store the result, and use another statement to continue the computation. The other thing is that C++ obeys the natural order of precedence. So what we have here is essentially a plus b times c. So it will first compute b times c, which is b as 5, times c is 3, so we'll get 15 plus a plus 7. This would be 22. And it would not just blindly go from left to right. So let's output here result and run this. So here as a result we get 22 because multiplication has a higher precedence than addition or subtraction. Now if we wanted to do it different, we could do, say, result 2, a times b multiplied by c. So if we want to have it left from right, we have to use parentheses. So I do a plus b, this will compute first, and after that we multiply by c. So here we would take a, 7 plus b, which is 12, 12 times c, which is 3, so 12 times 3 would be 36, and then that would give us the result for this one. So let's run this. And here you can see with this one, we use parentheses to compute the addition first, and then we get 36. I hope this gives you some idea how to use arithmetic operations in C++. Thank you for watching.